Okey-doke. Right. Hopefully you should all be able to see the slides now. Yep, they've come up. Okey-doke. Right. So morning, everybody. I'm Alex Howison, Director for Eclipse Power Optimise. Thanks for joining the webinar on private networks and microgrids, which we've effectively called the 101. So the webinar today is based on the idea of giving all of the kind of basic details on private networks and microgrids and the Eclipse Power Optimise offering overall. We've got a prepared slide deck, which I'll be running through, and some of you may be hearing I am a little bit croaky. So what I'm hoping to be able to do, if it's all right with you all, is to save questions towards the end, because that way I can stick to my reasonably random flow as we go through the slides, and then we can do a full Q&A session at the end. So we are going to leave time for that as we progress through. In terms of the webinar today, we have got some housekeeping points, which I'm going to hand over to my colleague Anna to run through. Anna, over to you.
Yep, hi everyone. Hope everyone's doing well this morning. So as Alex said, for this one, we are going to keep all questions to the end so we can get through all the content. If you want to put any in the Q&A tab as we go through, we'll answer all those at the end, and you can also raise your hand when we get to the end of the webinar. The webinar today will be recorded, and we will be sending that out afterwards, as well as the slides, if that's helpful to anyone. Otherwise, there will be some polls popping up throughout the webinar, so if you want to have your say, you can respond to those. Otherwise, we'll hand over to Alex and get going.
Reckon. Thanks, Anna. Right, so just a quick summary of what we're going to be covering off today. I'm going to give you a bit of an introduction to the group, so the Eclipse Power Group, the drivers behind why we've launched the Eclipse Power Optimise, basic details on what private networks and microgrids are and some of the regulatory points behind them, a quick summary of both private network and microgrid models, the cost benefits, some of the technical elements, and then some of the structures that we're putting in place in terms of the long-term ownership. So as I'm sure that you'll all appreciate, there is probably no opportunity to be able to cover every facet in the course of an hour or just under an hour. And a lot of the detail is obviously going to be very project specific as we look to individual projects. So today is just to give a decent overview in terms of the basics, and hopefully trigger a lot of your interest in terms of picking this up in projects moving forward. So the Eclipse Power Group. Eclipse Power has been around for some time now. I think the IDNO, licensed IDNO, has been around for 9 years or thereabouts. And that is a licensed IDNO that offers connection solutions and network ownerships within licensed network space. We have also got Eclipse Power Solutions, which is an industry-leading grid consultancy, helping on everything from kind of project feasibility, grid connections, all the way through to construction and long-term kind of regulatory impacts and reviews. Eclipse Power Optimise, that delivers private networks and microgrids, is the third business within the group. We launched on the 20th of January this year, and ultimately this is what the webinar is all about today. It is about the private networks and microgrid space, but it's useful for all of you to know that actually, as far as the group's concerned, we do offer a wider range of solutions. Just moving forward. So with the group, we do offer pretty much the end-to-end connection support across the industry, transmission and distribution network voltages, and the options within that of both licensed and unlicensed network solutions. And if you've got any concerns, confusion, or you don't know which sort of pot would be best for your project or your portfolio of projects, the consultancy is there to be able to walk you through some of those design feasibility steps, and to give advice in terms of what is best for you and your project moving forward. So we do offer, if you like, a completely agnostic view in that respect, that is based on what is best for your project, as opposed to either the IDNO or the private networks just driving that business forward. So what are the drivers behind Eclipse Power Optimise and why we've launched this new business? Well, most of your industry incumbents, so you'll be well aware of the fact that the grid queues in the UK are still significantly high. It's been a problem that's been about for a few years now, and despite things like connections reform, changing goalposts, and raising the bar to entry for connection, there is still a significant queue. When you look at some of the steps that are being taken from a regulatory and policy perspective, even when that queue is reduced, we are still looking at, a significant amount of new GSPs, large tracks of UK infrastructure from transmission pylons all the way down through to 132 and 33 kV network upgrades, which will be needed to meet even the projects that are left over in the queue once that queue has been trimmed down. So there's a significant amount of uncertainty there in terms of what can connect and when. You've then got the advent of Clean Power 30, and there's an awful lot of battery and renewable energy projects in the queues that face an increasing amount of uncertainty about whether they will actually be able to connect and when that connection might be obtainable. So even though we hope that initiatives such as connection reform will trim down the queue and bring a lot of those connection dates forward, there is then the knock-on impact that there is still going to need to be a significant investment in networks infrastructure to be able to enable a lot of those connections. So whilst we hope that those connection dates that have been issued for late 2030s will be brought forward, it is highly likely that there will still be clusters in the UK where 10 to 15-year delays to connection are still apparent. So within the environment, you've got an ever-increasing risk and uncertainty in terms of not just developers but investors. Will this project go forward? How can that project move forward? Will it be requiring a new GSP or a GSP extension? And then once that's been approved, the level of investment planning process to actually get that site constructed. As a result, there are projects out there looking to repurpose, change technology to try and broaden what the potential is to mitigate some of those risks. But again, the structures from a policy and regulation perspective, if anything, are getting more difficult and more complex. So actually, what could have been a change in technology, which we felt would have been quite simple 5 years ago, is becoming ever more increasingly complex to deliver. And when you take all of that uncertainty, increasing risk within the connection space and getting energy projects delivered, as a direct counterpart to that, we've got the existing government, which is quite rightly driving to try and improve investment in the UK, encourage growth, increase house building. So actually, we've almost got a bit of a perfect storm where there is more needed and less getting through. Where in terms of things like planning, the government is looking to try and remove red tape, whereas in the connection space, we're facing ever more increasing complexity in being able to get through to a point of connection. So we've also got, of course, the even wider drive to deal with climate change and net zero. So the UK as a whole is looking at the electrification of heat, transport. We do need more renewable generation. We do need it to be put in at places where demand is highest. And actually, the backdrop of that is an electrical infrastructure, which, whilst being one of the most reliable in the world, is still built around transport of energy from large centralized power stations and then out to centers of demand further afield. So, we finally have to recognize the fact that, because of, international events and drivers, fuel prices continue to go up. We have got uncertainty in terms of supply chain. And whilst we've got a very reliable network, there is still significant instability in terms of being able to pass savings in terms of generation of energy through to those users that need it the most. So, and it's been well documented. So I did actually forget that those pop-ups were there. So it's been well documented in terms of a lot of the drivers there. And I think for those of us that are industry incumbents, there is no silver bullet to this. And it is going to take some time to get that queue reordered and then to give developers and investors the type of confidence they need to be able to pursue projects. So we've already got a licensed IDNO, so that we feel we've covered the license piece. So private networks and microgrids give us the opportunity to deliver unlicensed networks. Now, they are subject to fewer regulations and limitations, and they do offer a range of benefits, which we'll cover off through the slides today, which can both cut through some of the complexity and the difficulties that licensed networks have got in terms of being able to provide those connections, and also their ongoing sort of development costs and ongoing management. So private networks can be delivered across all connection voltages, supporting all different types of customers. There are some restrictions which we'll go into a little bit later on, but ultimately one of the core advantages, especially when we come to microgrids, is the ability to encourage and connect more renewable generation and flexible demands, battery energy storage behind a point of connection to minimize what the actual point of connection needs to draw from the grid. So that can offer advantages in terms of, reducing time to connect and reducing the cost to connect, and encouraging the consumption of energy generation and battery storage at the point of need. Eclipse Power Optimise is built around the idea that we can tap into investment and bring up to 100% of the connections cost. So if you're looking to connect your project, usually grid connection costs, new substations, not just the potential reinforcement at your point of connection, is all a significant cost to a developer. We can bring that investment needed to build out the network behind the point of connection, and whether that includes substations, cabling, and all of the nuts and bolts that go with them, we can bring that cost in and recover that cost over the course of the network life. So there is the opportunity to significantly reduce the capex required for a developer in the whole build by extracting that electrical element and us covering that off. We can also, within the license space, apply joint venture ownership models, dependent on the project and developer requirements, which can trade off some of that maybe initial DevEx sort of cost for an ongoing income, and sharing what the kind of network tariffs can generate over a period of time. And then much as sort of the ID&O model, the idea is that with Optimise, we would then design any sort of alteration, provide O&M for the networks once they're energized. So if you've got a phased development, or you've got a development whereby more capacity is either available in-house through generation or at the point of connection, we can continue to support the alteration, the development of that electrical network to supply connections to different sites or to expand the amount of renewables that can be connected downstream. So there are some regulatory points. It's not a free-for-all working within the class exemptions. So whilst private networks and microgrids are unlicensed networks, they do still need to be safe and reliable. They do still need to adhere to ESQCRs. We are still subject to metering codes, and the ability to provide fair, transparent, cost-reflective tariffs. So we do still have to adhere to a lot of the industry regulation, but those class exemptions do mean that we can step outside of certain elements. There are, if you like, the class exemptions do have a tighter set of limits on domestic developments. So whereby a commercial and industrial development, you can have as many megawatts as you like, and we would apply that at different voltages. Really, the sweet spot when it comes to domestics, is far smaller networks that are limited to 1 MVA of load. The class exemptions, and I think it's B, do also stipulate a maximum level of a single generation source within those microgrids as well. So for the moment, you're probably looking at a domestic sort of microgrids and private networks being limited to about the sort of 150, 200 home marks. But there is the opportunity to apply for derogations and exceptions from Ofgem to try and support larger developments. And to be honest, through some of the early stage projects that were already developed, I think that there is an awful lot of interest in that ability to support larger residential developments. And therefore a fair amount of drive and the ability to obtain evidence base on why being able to apply these solutions for larger domestic developments would give a distinct advantage, especially where we're looking at the opportunity to bring energy bills down for homeowners, social housing. Microgrids really can deliver that type of saving. So whilst there is an awful lot of industry change that we're looking at, I think we are very much of the opinion that engaging with Ofgem, with regulators, with government about applying private networks and microgrids to larger scale domestics and looking at the opportunity to delivering these solutions at transmission level are all drivers that we're very much behind. And I think it's really key to draw that out, that in this mix of changing rules and regulations and connections reform and policy changing, from a government perspective, there has never been a better time to try and drive those solutions and to ask for what the art of the possible is, because there is a conflict there in terms of how long we know that getting the electrical networks in the UK up to speed to meet the required kind of development, whether that's through net zero, climate change, through AI growth, and through our increasing need for flexibility, renewables, and batteries on the system, and how long it takes to build that new infrastructure to get it connected, and to the level of kind of due diligence that is needed within the licensed network space. So we are already planning on some engagement to try and drive what the art of the possible is in terms of increasing the utilization of microgrids and private networks in the UK space. So just a bit of a kind of visual aid in terms of a standard private network. They are designed and delivered in very similar means to existing networks, but they do offer a fair amount of advantage. We'll dispel a couple of potential misnomers first off, which is the fact that if you're connected through a private network, it kind of limits your access into wider market pieces. There have been a couple of industry code changes in the last couple of years that do mean if you're a large scale generator or a battery storage, or you have a flexible demand and you're connected within a private network, you can still contribute to and be registered within the BM. You can also choose who your supplier is. So actually the kind of standard setup and historical setup for a private network is that there's a boundary metering point. The network owner applies the supplier to that boundary metering point and then sub-bills all the customers downstream. That's still possible and still supported. But now if you're a customer that's connected within that private network, if you wanted to change from, say, EDF to Octopus, you would be able to do that. And actually the metering code changes that have come in the last couple of years enable that to happen, and retain the kind of network charging that has been calculated by the network owner. So if your generation, your battery, your flexible demand, you can still be registered to the BM and provide those services to the wider grid despite being connected within the private network. However, there is also the opportunity to engage in, if you like, PPAs within between generation and battery storage to specific demands that are connected within the private network. So the provision of energy there, and the private network does support that. Obviously, it does still cover and support elements like phase construction, development options. We can look at building a network over time to meet your development requirements as your capacities ramp up, as new sites are connected, and stagger the kind of network build to, if you like, manage how the network capex and the overall DevEx is applied to a particular project. We can also apply similar optimization systems to private networks as we'd expect to install within microgrids. So the ability to manage load flows within the private network between generation and demand, and optimize how energy is consumed within the private network so that cheaper, low cost, locally generated energy is consumed first, as opposed to drawing on the more expensive energy that is provided by the grid. So it does deliver the opportunity to also reduce, if you like, grid energy consumption to keep as many of the electrons within the network, the private network, as is possible, and deliver cost optimization to the different connectees within the private network in itself. We will come to the point around sort of charging and how the kind of boundary point is managed as we go on. But again, I think probably the key thing to do is that this model and the following model, they are both indicative models. the idea with private networks and microgrid solutions is that they are designed for what your project needs, so they can be designed bespoke for an individual development project or a portfolio of projects to give you the confidence that your network is being constructed in the way that you need it to. One of the key advantages with the kind of private networks and microgrids is in the unlicensed spaces that we can utilize, if you like, non-standard, non-ENA approved equipment behind the point of connection. So we will obviously have to make sure that the point of connection is compliant, protection settings, fault level, all of that meets the DNO or the TO requirements at that point of connection. But downstream of that, so if the local DNO is insistent on copper cabling for their network, but we can use an alloy and aluminium, we would be able to utilize that between the step down substations and the points of connections within the grid to reduce those costs, or apply, if you like, the use of tier 2 substations, which do have higher losses, so they would impact the overall tariff, but they can dramatically increase supply chain requirements and the cost of delivering those networks. So we will look to, if you like, design those efficiencies in as through engagement with yourselves about the best way to deliver that network, and explain very openly and fully about what the impacts might be in terms of tariffs, or how we're recovering those, how we're covering the increase in losses. Moving on to microgrids now. Microgrids are based around the ethos that you are using the energy that you are generating locally. So if you like, against a private network which operates very much the same as a licensed network, where it is about having a grid connection that meets, or a connection to the grid that meets your overall and total capacity requirements, both for demand and generation. A microgrid is all designed around the idea of trying to minimize that relationship of passing electrons to and from the existing grid. So as a great example, we're working on the microgrid already, whereby you've got a number of domestic homes, you've got EV chargers, those homes are electrically heated, there's a grid scale battery, there's rooftop PV. So you've probably got a couple of megawatts there of demand alongside a couple of megawatt potential generation when you include the battery, but we're sticking it behind a far smaller grid connection. Now, we do need to use G100. We are putting an optimization and management system in, which has, Modbus, the MP3 protocol, so it can provide information required about how that network is operating. But ultimately, what we've been able to do with that is to dramatically reduce both the cost to connect, to provide a point of connection to the existing grid, reduce the risk, and in this point avoid completely any upstream reinforcement that would usually be triggered if you were looking at my worst case scenario, if all my generation or all my demand was going to hit that point of connection. By managing that, we've reduced the cost to connect, we've reduced the time to connect, and actually through the utilization of that optimization system within the microgrid, we are comfortable and confident that we can manage those load flows to keep as many of the cheap renewable electrons within the microgrid, which will drive cheaper bill for the connecting residents within it. So microgrids and private networks share the space that they're unlicensed networks, but a microgrid is built around, if you like, minimizing what the commercial opportunity of a battery storage device or rooftop PV is, and combining that in the altruistic sense that those devices are working together to improve, improve the kind of net zero impact and environmental impacts of that localized grid, and to dramatically reduce the cost for the residents within it. So they do have, similar some similarities with private networks. We can still look at, phased delivery options. We will still look at full funding of the construction of the network elements. We will be able to support the use of, if you like, non-ENA approved equipment within the development of a microgrid. But ultimately, if you like, the commercial space is just a little bit different, because it is around, keeping as many of those electrons within the microgrid as we possibly can. Again, customers that connect within a microgrid do still have third-party access. They can change their suppliers if they want to. it is about looking at how the metering is installed within a microgrid first to make that route as easy as possible. But ultimately you are looking at things like utilizing battery to absorb excess PV during the day when maybe load is low, using that battery to export in the evenings when everybody's coming through and putting their EV chargers on. And I do appreciate most of us will have heard what's happened in terms of Heathrow over the last couple of days. Keeping a point of connection that can cover base loads, having a battery that is sized appropriately, so in the event that all hell breaks loose and we lose something in terms of the point of connection to the grid, that the base loads for the households can be covered. And of course, when it comes to being a private network operator, we do have some flexibility around, if you like, the application of things like GS standards, but our customers are still going to want to have confidence in terms that in the event that something fails, a fuse blows or a cable goes, or there is some sort of an issue at the substation, we can apply, similar or the same or improved or relaxed, depending on your approach. Times to get to site to get those faults restored, the abilities to bring supplies back on. So just having a private network or a microgrid kind of name doesn't mean that we sidestep all of those obligations. We do still have to ensure the fact that we're providing a safe, resilient, reliable electricity supply, and that we can deal with faults and issues in a similar manner as a licensed network. So I think I've covered off a few of the cost benefits of private networks already, but we are shifting into some of the specific charging elements. I pulled this table together, much to the concern of some of the group colleagues, but I think it is important to be able to kind of pull out some of the key differences. I'm not going to read the slide verbatim because it will be circulated afterwards, but I did just want to sort of draw out on this one that, I've already mentioned, avoiding upstream reinforcement costs by, reducing capacity or the ability you can socialize those between connections. The fact that we can bring up to 100% of the construction funding required for the delivery of a private network and microgrid solution, I think, is one of the critical elements. And of course, that does drive in that variance that we can also look at shared ownership. So as opposed to funding all up front, we can look at sharing the ongoing revenues from the use of system charges. And we can do that and ensure the fact that actually things like the cost of investment is covered, utilizing similar models from EDCM and CDCM, but basing it against time of recovery, the ability to revenue share between a third party in terms of what that income is. And ultimately, again, the kind of energy charges, when you look more specifically at the microgrid level, the reduction in energy cost is being driven by the utilization of those locally generated electrons and using the battery to kind of offset charges from hitting, red and amber bands, and being able to draw energy from the grid, maybe in green bands, and be far more flexible about how energy is pulled into the microgrid and to the private network. So when you look at standard DNO connections, probably the greatest comparison, and probably one of the things that kind of drives that, why would you still be looking at that option, is the fact that you pay a network operator, a licensed network operator, for a point of connection. You pay them for all the equipment, and then once you're connected, you pay them for the use of that equipment over the lifetime of your connection, at least through both the IDNO space and more importantly the private network space. There is ability to be able to avoid some of those costs, or to recover some of the value for the assets that you as your connection are fitting to the networks. So ultimately, I do feel that looking at private networks and microgrids gives you the best option when it comes to how your cost benefit analysis and connecting to the networks. So I think moving beyond that point and just having a look at the next slide, just going to give a bit of a summary in terms of some of the technical elements. Now, again, this isn't an absolute crib sheet in terms of everything that we go through when we're looking at a private grid or a private network or a microgrid, but it is indicative of some of the key points that we need to be aware of. I think, behind this sits a very real want to be able to engage on a project by project basis to really understand, what your build program is, how quickly your project wants or needs to energize and ramp up their capacity consumption. Whereabouts are you building? What sort of timelines have you been given from the local DNO or TO? Have you even put an application in yet? And these are the sort of questions, and we'd rather be on board early as opposed to part of the way through, because we can help to guide some of those conversations and potentially avoid any of the challenges that would usually face from speaking to licensed network operators. So from a metering perspective, you've got full MPAN, parent MPAN, you've got child MPANs. There are fully private metering options. We've engaged quite heavily across the industry in terms of ensuring the fact that we've got an awareness as to what meters would be best and where, how they best work in terms of the charging. And there can be, if you like, bespoke options based on a project, but we still need to ensure the fact that if there's a need to, have full settlement, that, we're adhering to BCA, that therefore, the Elexon metering codes will all apply. And I think having compliant, and whether that's COP 1 to 10 metering, dependent on your connection type, depending on the customer type, having compliant metering, even in the environment where you've got private sub metering for different connections downstream, it avoids some of the longer term risk in terms of when you want to change supplier, or if a customer wants to change supplier, it means they're not having to look at meter changes further on down the line, although that is obviously a preference that can be mapped out in the early part of the project. I've already covered off the point that we can use non-ENA approved equipment, and we will obviously ensure the fact that we've got assurance that its safety and reliability of that equipment can be evidenced, and that we've got confidence that installing it won't erode the confidence we have in terms of that network remaining safe or being reliable, or providing a kind of a sustainable network moving forward. One of the things that I think is key, regardless as to the type of network that is being installed and where your project is that we will work very closely with the host DNO, the TNO, the IDNOs, and the system operators, to ensure the fact that not only we're providing a compliant point of connection, but the settings are appropriate, that they've got full awareness of what we are developing downstream of that. I think there's been some increasing challenges from DNOs in recent weeks. I've heard on the grapevine around the use of G100 and some of the supporting data that's been required for that. And I think it's a kind of a classic part of the energy industry that actually there are 6 different interpretations of what the rules will be when you look at the different regions and the different network operators, and we will help navigate through all of that, and we'll actually take ownership in terms of making sure we're managing that engagement, that we are providing just the right information, that we are challenging when we feel that there's a variance in how the interpretation of the rules is being applied, and that's something that we've got a lot of experience in. And ultimately, we will work very, very closely with the Eclipse Power Solutions business to kind of draw in on their experience on this, and and if needs be, get additional support in terms of how that engagement maps out. We do look at the full kind of end-to-end for these solutions, so whether it's the initial sort of concept and feasibility work all the way through to the network construction, delivery, and then the post kind of post-energization, O&M and asset management. We will cover the lot. And actually, when we look at that initial project formation, it forms part and parcel of what the expectations for you and your projects in bringing Eclipse Power Optimise in. we make sure that everything's market competitive. We're not looking at dramatically inflating or increasing the cost of things like O&M or asset management to try and make a swift buck. That's not what this is about. So when it comes to rates, we will have full transparency in terms of what that O&M looks like, what is the driver for it, so that actually whether it's a 100% Eclipse Power Optimise network or whether it's a joint venture, there is kind of full visibility about the charges that would be applied. And it's not just O&M, it's also things like utilization of systems, like the optimization systems or distribution management systems that would be put in place that form part and parcel of that ongoing network management cost. And of course, as you would expect, we've got existing relationships and maintaining relationships with OEMs, ICPs, ECPs. So where we've got that advantage is to bring all of the required points around the table when it comes to looking at the construction costs, where the risks are, how do we mitigate those, is there a particular issue with the local network operator, is there a regulatory point that might be coming down the future that poses a risk to this. The idea with Eclipse Power Optimise is actually we bring all of the required parts around the table so that you've got confidence that actually the one thing that is probably the most risk assigned element of a development at the moment, which is that electrical connection, is you've got a trusted partner on board that at any given point of the day can bring the required parties around a table to put solutions in place to manage those issues and to give you confidence that your project will go ahead, will achieve a connection date, and will be delivered at cost and on time, based on the type of solution that you want to apply. So just as a bit of a kind of extension of that, it's a very loose and high level process that we would go through. This is based on projects that we're already in delivery of, and a lot of the conversations that we've had already. So in terms of that process, we'll go through the concept of feasibility works. Now, it could well be that you're already working with consultants, you've done your own internal sort of modelling, you've got a rough idea about what it is that your connection needs and the network that it would need to support it. If it's a reasonably straightforward one, you've probably got confidence already, but you may well be coming to the table quite early and need that support in terms of actually what does a solution look like. I know I've got a 20 MVA data center. I know I've got 300 acres there that's available for PV, but actually what does this look like and what does my point of connection need to be? And we can support you through that, both in-house. We've got trusted external partners that we can use to help in terms of some of that feasibility as well. We'll then go through and we've built a financial model that we can turn all the dials on ultimately. So if you're bringing investment or if we're bringing the investment, they may well have different, they'll obviously have different ticket sizes, but they might have different interest requirements. They might have, changing requirements based on what phase of the construction we are. So, once you've got to the point that you're energized, obviously the risk drops away. When we're looking at how quickly or how staggered your capacity ramp up is, our financial model can cover all of those points. So ultimately, we work with you to pull all of the kind of feed-in information together and then build some scenarios about how the network revenues would work over a period of time, how quickly the investment required would be a payback, and actually, if there was an interest in revenue share, what that looks like over the period of time. We will then go through and reasonably standard kind of contract delivery. We're looking at MOU, HOTS, shareholder agreements, SLAs, etc. And then once all of, if you like, the important stuff is done, the contracts, and we've got agreements there, we will then manage the delivery and the construction all the way through to the point of energization. Bear with me for 2 seconds. Apologies. And there's some loose timescales there, and it really does depend on where your project is and the complexity in what we're looking at, both from a technical end, the network, commercial end, in terms of how the relationship will work. That really drives the timelines. But ultimately, we will move as quickly as we can based on your requirements. just in terms of some indicative kind of charging models. Now, it's probably one of the questions that comes up the most when we're looking at this is actually, how does tariffs work? Well, we've obviously still, in certain cases, got to provide charging statements that are either published or provided to Ofgem. Not in all scenarios, but in some. But regardless as to whether we're putting a formal charging statement together, we still have an obligation to make sure that network charges are fair and transparent and that they are cost reflective. So, just in terms of some of the, and this is a very, very basic overview of one element of our financial model. We look at a total amount of capex required to actually construct the network. You've got a number of customers that are connecting, but at different times, and I've not brought through the challenge of a specific ramp up in this model because I did want to keep it as accessible as I could. Now, ultimately, much like any other normal network, if you've got multiple customers connecting, you've got an overarching network, which for this model we've said is the non-contestable. So this is the kind of socialized network element. And then you've got connection specific costs. So for example, we've got a 132 kV point of connection. We've got a set of 33 kV bars where the individual connections are going to be made at. A couple of those connections might need to connect at 11 kV. So you've got the requirement for an additional step down transformer and some additional network in that. But we've split out to make it accessible for those of us that are very used to seeing, if you like, DNO connection offers, and just split out those cost elements. Now, in this scenario, the first customer connect for at least the first year is picking up quite a meaty charge, because actually they're on the hook for the both their connection specific and the socialized network element. So they've got, and if you look at the bottom of the slide, they've got quite a high rate, and these are indicative only. This was thrown together on a train on Friday evening. They've got, if you like, the highest unit price when it comes to the network charge element. But as customer 2 connects, then as customer 3 connects, and then eventually as customer 4 connects, the numbers are adjusted based on what's been paid up to date, but keeping to the original timeline to have that initial investment repaid. So each time a customer connects, each time capacity ramps up, we can set the model to deliver a certain tariff reduction, and almost work on, if you like, a cap and floor. We'll know what the highest tariff is and the lowest tariff is for an equivalent connection from the local DNO, thanks to the fact that they publish their prices. So we can work in that model, but ultimately tailor both things like payback, and it could well be that if you're bringing investment, you might want to look at a 30-year payback or a 10. It may well be that you want to set, an absolute maximum price for the customers connecting within it, or an absolute minimum, or track it based on what price fluctuations are being applied through local DNOs. We can put in whether these track rates of inflation and map that out as well. We can also look at standard, if you like, increases to things like O&M and the asset management fees. So the model is very, very adaptive to all of those variables, but based around the, if you like, the cornerstones of how much is it going to cost to build this, who's bringing the funding in, and what are the kind of prerequisite criteria for that, and then spitting out tariffs that provide, if you like, the lowest cost over time for individual customers, or collectively across a group of customers. And the idea being is that whilst there are different tariffs being applied to different customers at different stages, they are all based similar to CDCM and EDCM in terms of what that cost of the network is, how much it costs to maintain, and how much does it cost to keep serviceable over a period of time. So, whilst there is some variance from customer to customer, they're all being calculated within the same methodology. And actually, as capacity and consumption ramps up, those costs are coming down for everyone, not just for one customer or another. So that's just a bit, and as I said, the model is drastically complex, but it does give us the ability to look at different scenarios that feed into the conversations about how these will be delivered. I'm really conscious of time because, as those of you that know me know, I do love a ramble on. So I'm going to get through these last couple of slides as quickly as I can. And they just give a bit of an indication as to some of the structures that we've already looked at and are applying within existing projects that we're delivering. So ultimately, in terms of setting up a grid code to deliver a project, we've built this model to help illustrate the fact that shared ownership is there, how connection and charging agreements would be delivered by the grid code to the individual connections downstream, the fact that we can bring kind of EPC, IPC, we can bring the O&M and assets, but we'd also look at hosting the optimization system and working with the developer of that system to ensure the fact that the criteria for the network and making sure that we stay within the limitations of the grid connection were maintained. So actually we pull all of that in as part and parcel of the grid code. But if you did want to view the potential for a joint venture opportunity, and like I say, look at longer term income generation from a localized network, this is the type of model that we would propose and we'd structure the conversations around. Beyond that, we have also got a lot of engagement with developers that have got multiple projects, and whether they're multiple large-scale projects or smaller scale, things like EV charge hubs. What you wouldn't want to do is to go through all your contractual technical negotiation on a project-by-project basis. So actually looking at a kind of holdco, an overarching agreement that would then deliver multiple projects internally, and look to, if you like, socialize cost and incomes across those. That is another kind of structure that we're looking at on a couple of the projects that we're working on already. All right, so there are a couple of different iterations, and I think it's probably key to state, what we're not looking at doing is the ownership or the funding of specific assets. All right, so we're not looking at of directly owning a battery or a wind turbine or a biofuel or even kind of an industrial or commercial customer. We are focused on the networks. But the advantage of the kind of private network and the microgrid model is we can directly control those assets to ensure the fact that that localized network is utilizing as much of the energy locally, is generating savings and energy efficiencies and cost efficiencies for its connected customers, and is maintaining its relationship with the wider grid through the point of connection that has been worked as being the optimum solution for that development. We can bring parties and partners to the table to look at some of those other elements, if needed, but we're there focused on the network because that's what we're best at. So just as a kind of, I think, final slide for me, just to reiterate again that we will deliver end-to-end services that cover pre-construction, the feasibility, the concept, the detailed design, the assurance, all the way through kind of project delivery and asset management. And ultimately, that is not just us, that's the Eclipse Group that offer these services. But yeah, it's not a kind of one-hit wonder. We're not looking at just getting involved at this point. It is about the end-to-end delivery and support in which we're focusing on. And then a last kind of point in terms of the slide is that I think it's very, very easy to think that things are either getting better or getting worse when it comes to the electricity connection space. I think in the 25 years I've been with the industry, and definitely the last few years that I've probably been more active within the connection space, there is, I think, a maintained level of complexity and risk, and I think often confusion about how certain decisions are going to interact with other ones. Eclipse Power Optimise and the Eclipse Group as a whole is very much focused on trying to make this journey simpler and to provide as many different types of solutions that our customer base is going to need. There will be, I'm sure, questions. There'll be specific events that pop up on a project by project, kind of basis that we may not have seen or that might be new, but I think we are best placed in the industry to be able to provide answers to those and to manage the problems as they arise. So ultimately, that is what we're here for, is to make the connections process simpler. All right. we're now onto the Q&A, and I think for the Q&A session, I mean, I've obviously been very much focused on reading through the slides. So hopefully Anna's been able to keep an eye on questions as they come through. I'll hand over to Anna if anything has popped up in the Q&A.
Love it. Thanks, Alex. We've got a couple in the Q&A section. So the first one is Eclipse Power Optimise only possible where Eclipse is the adopting IDNO, or would a client still be able to go out to competitive tender for IDNO adoption and adopt for a microgrid managed by Eclipse Power Optimise on site?
Good question. Thank you, Anna. So no, in some scenarios, having an IDNO kind of adopt the point of connection or a transformer at the point of connection may well be best for your might be best for your project. It's not critical, and we definitely don't have to ensure the fact that IDNO is Eclipse Power Networks. We'd love it if it was, but actually I have no preference, and we are separate organizations. So if you did have a substation that was being adopted by another IDNO, yes, you could connect a private network straight to it. But you can connect a private network direct to an existing DNO or TO network. There would need to be an additional kind of metering there, and the transmission question is still one that we're working through from a regulatory perspective. But yeah, there isn't a need to go or to apply an IDNO in between the two. So you can go full private network if you needed to.
Perfect. Thanks, Alex. So the next one, DNOs are wanting to restrict generation connections of times 1.25 at the point of connection. If you had a 1 MVA connection, the DNO would only allow 1.25 MVA of generation behind the point of connection. How will private networks or microgrids get around this?
Well, I think I'm quite comfortable in the fact that we've already got an example of where a DNO is allowing more than that, and I think ultimately it is about having that engagement there. I know the 1.25 is a kind of a traditional approach engineering requirement, but the use of G100 and putting in an optimization system that gives a suitable level of confidence that we can manage the loads and generation behind the meter. As far as I'm concerned, that kind of 1.25 is something that I've seen thrown up, but we have already got a DNO that is working with us that is allowing more than that. So I think it is about keeping up positive engagement, going through, really explaining what you're doing behind that point of connection. And if you are still pushing up against that brick wall, it is knowing when to dig your heels in and potentially escalate, bring in additional support. Because that 1.25 limits, and I think we'll have a kind of broader limitation in terms of the development in total. But like I said, we've already got a DNO that is comfortable with the fact that we've exceeded that 1.25, and they're happy to work with us, and that site should be connecting this year.
Perfect, thank you. Next one, on a private network with more than one customer connected, could you provide multiple MPANs downstream of the boundary point, regardless of security of supply of the main supply? For example, single circuit supply with multiple MPANs on the private network.
Yeah, you can. It needs a little bit of, it will have to go through a conversation just in terms of actually how the kind of supply and billing works. But yes, you can have multiple MPANs connected within a private network. There are almost two questions in that though, Anna. So the metering one, we'll take that aside. Absolutely, yes, you can have multiple MPANs registered to a private network. But you then mentioned security of supply. Now, ultimately, I think that just a kind of broad point I want to make on this. EQSS Chapter 3, P28, and if you like, that security of supply points are focused of licensed network operators. So providing full Chapter 3 compliance and P28 is a license requirement. As an unlicensed network, we don't have the same requirements. So ultimately, designing a system to meet our customers' needs within that private network, we have a certain amount of flexibility, and ultimately, we may well be able to provide assurance in terms of the firmness of supply through generation that's connected within the private network by looking at designing the network in such a way that there's redundancy within the private network itself. So there there were two questions in that one, and I think the idea being is that yes, metering absolutely fine. In terms of the security supply piece, we do have greater freedom, and I think again that is down to us as the private network operator to identify what it is that our customers need, and then go and negotiate with the licensed network operator that we're connecting to about why we're able to do what we do and why we don't need them to design out a network that is 1.7 times more resilient than it needs to be.
Thanks, Alex. Next one is, will fault level headroom in the DNO network be an issue to bringing sites forward?
I think fault level is a residual issue for any type of connection. We as a responsible private network operator do need to ensure the fact that we've calculated fault level correctly for the assets within the private network, and we're having that conversation with the DNO or the TO that we're connecting to. So fault level will remain a bit of an issue, but within the private network, I think again we have got that ability to be able to look at fault level management. We are able to look at in the same way as any type of development will cable lengths and cable routes, will transformer setups and configurations. Will fault level limitation devices be able to adjust it? Absolutely. Can we employ those and design those into our system with greater flexibility than a standard licensed network? Yeah. So it is about knowing what the fault level requirements and limitations are at the point of connection, and then designing that network downstream of it to suit. But we have a responsibility to be upfront and to have accurate calculations about what our fault level is within the private network or microgrid, and then having that discussion again with the licensed DNO or IDNO that we're connecting to.
Thanks, Alex. Just a follow-up from the one regarding IDNO adoption. If there was a non-Eclipse IDNO adoption between point of connection and private network, would it still be possible to have individually metered suppliers on site where users could select their supplier?
Yes, it is, and it's actually, if you like, a requirement that a connected party within a private network can have third-party access. So yes, it is still possible, even if it is any one of an IDNO and then a private network downstream of it. But the metering configuration, you just need to ensure the fact that you've worked with a meter supplier, with the supplier that you're looking in terms of having responsibility on site, and agreed the metering configuration in general for the site where your boundary meter is going to be, what assets are actually being metered within the private network or microgrid, and then the types of metering that is being installed to those to enable third-party access. So yes, it is still possible. But again, the more complex a particular project gets, the more we just need to ensure the fact that we've had those conversations and that we've worked through a feasibility study to iron out where those challenges will be to be able to deliver the network to meet the requirements.
Thanks, Alex. Next one is, what risk does third-party access have to your model?
I don't. It just has a risk that you just need to ensure the fact that that you have designed your private network and microgrid to enable third-party access. So it doesn't so much create a risk. It's more about having an awareness about what the implications are in terms of everything from your compliant meter design through to the metering configuration of the wider private network to ensure the fact that you have got boundary metering, that you are able to meter the individual sites, not just the individual demand or generation, but the different sites within your microgrid. In terms of the assigned network charges, you will have a network operator reference for that private network and microgrid, and your charges will be assigned against that network operator reference. So regardless as to whether a third-party supplier is brought in or whether it's the host supplier that you've organized, you have set your network charges for that network. So actually the ability to recover network charges is maintained because the network itself is setting the network charges. The supplier is picking up the other 80% of the bill as it would do in any other scenario. So yeah, I don't think it is a risk from enabling third-party access, but it will increase potentially the cost to deliver the metering, and the complexity in terms of that metering arrangement in total.
Thanks, Alex. Conscious of the time, but we've got 2 more, so I'll try and get through them if everyone's able to hang on. So the next one is, with Clean Power 30 and grid reform, could a private network or micro network be considered an innovative or new technology to attain strategic alignment?
I think, private networks have been around for donkey's years. If you've travelled through a UK airport or port in the last couple of years, or you've been on an MOD base, you've been within a private network. I think, to really apply innovative, it's about taking something that's been done before and using it in a new way, or pushing the boundaries of how it can be utilised to meet a new need. So I think in microgrids, the historic challenge has been, actually making them financeable. That, with decreasing cost of things like PV and battery storage is becoming less of a challenge now. But yeah, I think, looking at projects, definitely some of the larger domestic ones that we're looking at, or potentially pushing the boundary in terms of what's allowed from a regulatory perspective, could be considered innovative. But again, I'd want to have a look at that on a project by project basis. But it aligns with some of the things we're already thinking